Okay, today we're going to be talking about correlation versus causation and correlation coefficient. Correlation, the difference between correlation and causation is correlation is when two variables are related. But one doesn't cause the other. And causation is when one variable causes another variable to change. So it has to cause the other one to do something. So we're going to practice some of these, and some of these are kind of hard to tell whether it is causation or not, but it's the one, like for instance, this one, we want the one that is not causation, so it's going to be the one that we feel doesn't cause the other one. Okay, so we're going to read these, and we're going to decide yes or no, does it cause the other one or not. The amount of rainfall received and the level of water on the lake. So what happens when it rains? What happens to the lake? It gets more water. Okay, so if it gets more water, then the more it rains, the higher the water on the lake is going to be. So the rain causes the water to rise. So this is true. The second one, the number of lights left on each day and the amount of the electricity bill. What happens if I leave all the lights on? What happens to my electricity bill? Does it go up or down? Up. What happens if I turn the lights off? What happens to my electricity bill? It goes down. So does me leaving the lights on every day cause my electricity bill to change? Yes, so it does cause it, so it is causation. So I'm going to put a check because it is true. The increase of warm sunny days and the number of ice cream vendors visible. What does that mean? That means if it gets warm outside, then I'm going to see more ice cream vendors. The ice cream trucks. Am I going to see more of them if it gets warm and sunny? Maybe. Maybe not. Who knows? So let's put a question mark on that one, because maybe it does, maybe they don't. I haven't seen a lot of ice cream vendors outside when it's hot, right, in the winter. Maybe in the summer, but not in the winter. Just because it gets warm and sunny doesn't mean I'm going to see more ice cream trucks. And the last one, the number of hours worked and how much money is made. So if I work more hours, do I get paid more money? Si trabajo más, ¿me pagan más? Yes. And if I work less, do I get paid less? Yes. So this is a true statement. One causes the other one. So the one that is not true is this one. Okay, this is not causation. Just because it's warm and sunny outside doesn't mean you're going to see more ice cream vendors. All right, let's try number 2. Which one is not causation? Okay? The number of tardies in class and the number of detentions received. So if I'm tardy to class more times, do I get more detentions? Yes or no? Yes, more tardies equal more detentions. The second one, the season of the year and the number of water-related injury deaths. So if the season changes, do I get more deaths by water? Maybe, maybe not, right? It just depends where you are. What if there's no water? There's no lakes by where you live, right? So let's put a question mark because maybe, maybe not. As the temperature rises, the mercury in the thermometer will expand and rise. Remember, mercury is the stuff inside the thermometer. So if it gets hotter, does the stuff inside get higher? Yes. And when it gets colder, does the mercury get lower? Yes. So this is true. Here's my thermometer. Right? When it gets hotter, the thermometer rises. Let me erase all of this. And then, the last one. The larger the dimensions of a rectangular patio, the more square footage. So if my dimensions are bigger, me draw a rectangle. If my dimensions here are like this, and then my dimensions here are larger, is there more square footage here? Yes. So the larger the dimensions, the more square footage there is. So the answer for this one would be here. So it's a little bit hard to understand causation. You just have to read them carefully and be able to tell yes or no. Does one cause the other one to change? Okay, so down here, now we're going to get into correlation coefficient. The correlation coefficient acts like a rating system telling you how well the line of best fits the data. So we're going to write down here correlation coefficient. Correlation coefficient. Right here. And this is going to be the letter R. We're going to be using the letter R for the correlation coefficient, and you can find it in Desmos, and we're going to try it in just a little bit, but we're looking for the letter R, not R squared, just R. So here is how to rate it, and we're going to put numbers on here, on these, when they're weak or when they're strong. So let's look at no correlation. If something is no correlation, then it's going to be 0. Okay, so this one would have a rating of 0. No correlation. That means they're scattered all over the place. Really strong, -1, that would be this one, the perfect negative correlation. So this would be like a -1. What about the strong positive one? That would be this one, right? Because it's perfect and it's very strong, so it would be a number 1. But what about if it's strong positive? Right? Because in the middle right here would be positive correlation, but the closer I get here, the stronger it gets. So what number is about right here? Maybe 0.8. So this is about a 0.8 because it's strong. But when it gets weak, it would be maybe around right here where it's 0.3 maybe. So this would look something like a 0.3. What about over here? Strong negative. What number do you think this one would be? It would be maybe right here in the middle, -0.8. So this would be a -0.8. And this one is still negative, but it's weak. So what number would that be? -0.3 maybe, or -0.4, or -0.5. These are just estimations. They don't have to be exact, but they have to be close to it. Okay, so yesterday we did these type of problems where they give you the table and we have to find the equation. Well, we're going to use the equation y1 approximately mx1 plus b. Okay? And we're going to put this table in Desmos. But we can't put it in with these numbers, right? So if this is 1990 and this is when we started, what number is that? 0. And then 1995 is how many years later? 5 years later. And then 2000 from 1990 is how many years later? 10. This one's 15. This one's 20. And this one is 25. So we're going to go ahead and put this table in Desmos, add a table, and let's put it in there to find the equation. So everybody open up Desmos, add a table, start typing 0, enter, 5, enter, 10, enter, 15, it starts typing it for you, 20, enter, and 25, enter. On the other side, we're going to put the decimals. So 4.22, enter, 4.35, enter, 5.39, enter, 6.41, enter, 7.89, enter, and 8.43, enter. And then we can zoom out to look at them. Oh, what's wrong with this? We can zoom out a little bit. Here's my correlation. So when I type my equation, y1 approximately mx1 plus b, it draws me a line that goes through the correlation and it gives me the equation. Okay? It also gives me the R. Does everybody see the R right here? This is the correlation coefficient, 0.98. Is that a strong correlation? Go back and look at your notes. That would be in between these two, right? Where it's almost perfect, but it's not. So the R that we just got is right here, 0.98. So it's almost close to perfect. Okay? So that's how I know that it's going to look something like this, almost really close to perfect. So right here we're going to type the equation. It's going to be y equals, and right here the correlation coefficient, R equals 0.98. Okay, so what was my equation? Let's go look. My M is 0.19. If I round it, 0.19. So I'm going to put y equals 0.19x. Don't forget your x. Plus 3.78. Plus 3.78. So I'm going to write it down and I'm going to type it again in decimals because we got to go find in what year did the average reach 15. So I want what year, the x, that gives me about 15. Okay? So let's go look. We're going to type it in decimals. The equation goes right here. So y equals 0.19 x plus 3.78. And then hit the settings because I need to open up the table for that one. So hit the settings and open up the table. And we're going to just start enter, enter, enter until I reach 15. So just keep going. Keep pressing enter until you reach 15. How long is that going to take? It would be around 59 or 60, right? One of these two. Oops. Where is it at? Because 59 gives me 14.99, that's almost 15. And then 60 gives me 15.18. So let's just say 59, we will reach $15. So 59 years later. So if I add 59 to 1990, how much is that? So 1990 plus 59 years later, that's about 2049. So year 2049. Remember, I added 59 to 1990. Okay, we're going to do a quizzes, so look out for the code.